We are going to verify some identities. I thought I'd try something new and put my little face in the bottom there. Let's see. My handwriting is probably going to be terrible, but what's new? We're going to verify if 1 plus tangent squared x over cosecant x secant x is equal to tangent x. Okay, so ultimately what we have to do is we're going to simplify the more complicated side. And we did simplifying with the last section, and it was just very simple stuff. So mainly what you want to look for, some of the things that I'm definitely going to be looking into is I always recommend you start with these secant and cosecant and try to switch them. But sometimes something else stands out to me, like this 1 plus tangent squared. 1 plus tangent squared, if you look over here in your trig identities sheet, tangent squared plus 1, well, isn't that the same as 1 plus tangent squared? Yes, it is, because you can add in any order. So ultimately, 1 plus tangent squared is the same as tangent squared plus 1. So this is equal to secant squared. All right, so I've got secant squared x over cosecant and I'm leaving the x's in. Sometimes I get lazy and drop them, sometimes I don't, but don't let that confuse you. All right, so I've got secant squared over a secant. Well, this secant x will cancel and the squared part will cancel there. So that's going to leave me with secant x over cosecant x. And from there, now I'm going to use the reciprocal identities and see what we can do. So secant is 1 over cosine, so 1 over cosine, over cosecant, which is 1 over sine. Okay, and then this is where we're going to do the keep, change, flip. Okay, not proper mathematical language there, but I try to keep it simple. So it's going to be 1 over cosine, change it to multiplication, and flip the other one. So that's going to be sine over 1. And so here we have sine over cosine. And what does sine over cosine equal according to our quotient identities? Well, sine x over cosine x is definitely tangent x. We have just verified it. Next example. Now for some reason that circle's coming with, oh well. This one is probably one out of your book, but I think the book does it a little differently than I'm going to. I got 7 sine theta plus 5 cosine theta. Okay, again, theta or x, it doesn't matter. Over sine theta cosine theta equals 7 secant theta plus 5 cosecant theta. So when I see this, I look at it and I'm like, oh my goodness, what am I going to do with that? Well, I start with, okay, I have a sum over a single denominator, so let's split it. I see things in the numerators. I've got sine on top and sine on bottom, cosine on top, cosine on bottom. So I'm thinking, ooh, stuff can cancel, but I can't cancel it right now. So let's get it to where we can do some canceling. That's when we split it and write it as 2 different fractions. So we're going to have 7 sine theta over sine theta cosine theta plus 5 cosine theta over sine theta cosine theta. And at this point, we are able to cancel. So in the first fraction, I've got the sine that will cancel. The sines will cancel, leaving me with 7 over cosine theta. And then over here in the second fraction, the cosines will cancel, leaving us with 5 over sine theta. Well, again, here's that reciprocal identity. I've got a cosine in the bottom, so if I want to bring it out of the bottom, I'm going to use the reciprocal. And the reciprocal of cosine is secant. So this is 7 secant theta. Weird. That's a secant. It put an O in there because it's weird. I'll make that the theta. Plus 5, and then sine's on the bottom, so the reciprocal of that is cosecant. 5 cosecant theta. Okay, so, and look, these two are definitely the same. It is verified. Check. Next example. Let me bring down this identity sheet in case we need that. Okay. Example number 3. This one's going to be secant x minus tangent x, and then 1 plus secant, sine, and we're going to verify that it equals cosine x. Okay, my instant thought here with this equation is to multiply. So we're going to FOIL. We're going to do the first term. So secant times 1 is secant. And then secant times sine plus secant times sine. And then negative tangent times 1 is negative tangent. And then negative tangent times sine. Okay, it's not very simplified yet, but we're getting there. So now I'm going to see what happens when I switch. I'm going to have, this is going to be 1 over cosine plus, well, secant is 1 over cosine. And then this is times sine over 1 minus tangent. I'm going to leave that one as tangent, and then I'm going to leave this one for now. Excuse my son, he's obnoxious. Okay, 1 over cosine plus sine over cosine minus tangent minus tangent x sine x. He says hello.
I'm a cowboy.
Okay, sine over cosine right here that I circled, this is tangent. So 1 over cosine plus tangent minus tangent x sine x. Okay, so these guys right here, tangent, positive tangent, negative tangent, cancel each other out. Say goodbye.
Bye.
Now, we've got 1 over cosine. Why is it doing that? I don't know. Minus sine over cosine, because tangent is sine over cosine, times sine over 1. Oh, well, that's interesting. So I've got 1 over cosine minus sine squared over cosine. That can be rewritten as a single fraction. So 1 minus sine squared all over cosine. Well, 1 minus sine squared, there's your another Pythagorean identity. Okay, the first Pythagorean identity, 1 minus sine squared. We can manipulate that. We can subtract both sides. So 1 minus sine squared equals cosine squared. So this is cosine squared over cosine. And then they cancel. And so our final answer here is cosine x. Okay, and there it verified because that's what we were trying to prove. Check, check. Okay, after the dog going crazy, I had to stop. Blah, blah. Here's the last example. Ultimately, we're going to look at sine A over cosecant A plus cosine A over secant A. Does that equal this other craziness? Well, let's just start with what we can do. I'm going to leave the cosecant squared minus cotangent squared alone for now, and I'm just going to work on this side. So I've got sine over 1 over sine plus cosine over 1 over cosine. Okay, we're going to keep change flip. All right, so when we keep change flip, this is going to be sine times sine. This is going to be sine squared. So sine squared. This one also, there's that dang O again. It's driving me crazy. Get rid of the O. Okay, so here's the 1 over cosine. This one will also be cosine squared. Well, according to our Pythagorean identities, the very first one says that sine squared plus cosine squared is equal to 1. Okay, so sine squared plus cosine squared is equal to 1. Now, I don't want to move that thing either, so I've got to grab my other, I've got an extra trig identity sheet right here. So if I look, I'm looking at I've got squared things on this side, all right? So that side's got squared things. Cosecant and cotangent are in the third Pythagorean identity. So the third Pythagorean identity, this is just kind of a side here. The third Pythagorean identity is 1 plus cotangent squared equals cosecant squared. Oh my goodness. Same old styles, making tons of mistakes. Cosecant squared. Okay, so we can manipulate this. We subtract the cotangent squared. We get 1 equals cosecant squared minus cotangent squared. Oh, cosecant squared minus cotangent squared. That's also 1. Does 1 equal 1? Yes, it does. So there is another way to verify identities.